Welcome to my sixth tutoring session in A-level chemistry. In this video, I'll give a detailed explanation about molecules, compounds, and ions with suitable examples. I will also be explaining the driving force for the formation of ions and salts. Molecules and compounds are two fundamental concepts in chemistry that describe different aspects of chemical substances. Now, here's an explanation of both terms with suitable examples. Molecule is the smallest unit of a chemical substance that retains the property of that substance. And molecules can be composed of only one type of element, as in the case of diatomic molecules like hydrogen, oxygen, and fluorine, or it can also be composed of different types of atoms bound together, as in the case of water molecule, carbon dioxide, and methane molecule. A molecule exists as discrete entities and they are held together by covalent bonds. Now, in all these examples, you will find that molecules are made up of either same type of atoms or different atoms. A compound is a substance composed of two or more different elements chemically bonded in fixed proportions. Compounds have unique properties that are different from the elements from which they are formed. In case of compound, both covalent bonds and ionic bonds are involved, and these bonds hold the elements together in the compounds. When you observe the examples for compounds, you find that they are made up of different elements. Let me explain the meaning of fixed proportion or ratio in the definition. Now, compounds are represented by the chemical formula, example carbon dioxide and carbon monoxide. Now, in case of carbon dioxide, the ratio of carbon to oxygen is 1:2. That is, for every carbon atom, there are two oxygen atoms covalently bonded. In case of carbon monoxide, the ratio of carbon to oxygen is 1:1. That is, for every carbon atom, there is one oxygen atom. Now, when the ratio changes from 1:2 to 1:1 in terms of carbon and oxygen, you find that you end up with an entirely different compound. So, when the ratio changes from 1:2 to 1:1, the compound changes from carbon dioxide to carbon monoxide. It is totally different compound. So, that's the meaning of fixed proportion or fixed ratio in the definition. As the ratio changes, the compound also changes. So, remember these 2 points. Molecule is made up of same or different elements, while compound is made up of different elements. Here's a representation of formation of molecules and compounds. Formation of fluorine, hydrogen fluoride, and sodium chloride. Now, fluorine molecule is formed by equal sharing of electrons between two fluorine atoms, and fluorine molecule is non-polar in nature because both the atoms are identical and are of same electronegativity. Hydrogen fluoride is formed by unequal sharing of electrons between hydrogen and fluorine atom. Hydrogen fluoride is a non-polar molecule, it's a polar molecule due to unequal sharing of electrons between the hydrogen and the fluorine atom. Formation of sodium chloride by transfer of valence electron from sodium to chlorine, resulting in formation of sodium chloride. Now, fluorine molecule is non-polar because both the fluorine atoms are identical and are of same electronegativity, while hydrogen fluoride is a polar molecule because fluorine is highly electronegative in nature and tends to pull the electrons towards itself, resulting in a polar covalent bond. This is a different topic altogether, and that will be discussed in my forthcoming tutoring sessions under the topic electronegativity and dipole moment. Now, ions are electrically charged particles that result from the gain or loss of one or more electrons by the atom. They can be either positively charged, called cations, or negatively charged, called anions. Ions play a crucial role in chemistry and are involved in various chemical reactions. Here's an explanation of ions with suitable examples: sodium ion, chloride ion, hydrogen ion, oxide ion, ammonium ion, sulfate ion, and nitrate ion. Let me explain the mechanism involved in the formation of ions. Ions are formed when atoms undergo a process called ionization. What is ionization? It is a process which involves gain or loss of electrons. The number of electrons lost or gained determines the charge of the ion. So ions formed by gaining or losing electrons in order to attain stability similar to noble gases. I'll explain that part in detail with the help of diagrams and animation. So what are cations? Cations are positive ions. Now, cations are formed when atoms lose one or more electrons. This results in more protons than electrons in the ion, leading to a net positive charge. So common metals tend to form cations. So anions are negative ions, and anions are formed when atoms gain one or more electrons. So this results in more electrons than protons in the ion, leading to a net negative charge. Common nonmetals and some polyatomic ions form anions. Sodium in the elemental form loses its valence electron, resulting in formation of sodium ion attaining the stable neon configuration, while chlorine, it gains electron given by sodium and attains the stable argon configuration. Now sodium gives its outermost valence electron to the chlorine, and chlorine accepts this electron given by the sodium, and that results in formation of sodium chloride. Now sodium in the elemental form has the electronic configuration of 281, and after it loses the outermost valence electron, it attains the stable electronic configuration of neon. Chlorine has electronic configuration of 287, and after it gains an electron given by sodium, it attains the stable electronic configuration of argon, that is 288. Now why is that sodium is attaining the stable electronic configuration of neon and not that of argon? And why chlorine is attaining the stable electronic configuration of argon and not that of neon? So I'll explain this part in detail. Now what is the driving force for the formation of sodium chloride? Let us try and find the answer for this question. Here's a simplified and condensed version of the periodic table. You can identify an element in the periodic table by its atomic number, by its symbol, by its name, or by its atomic weight. So the easiest way of finding an element in the periodic table is either by its symbol or by its name. Now, sodium is the 11th element in the periodic table, while neon is a stable inert gas, is the 10th element in the periodic table. Chlorine is the 17th element in the periodic table, while argon is the 18th element in the periodic table. Now, sodium, it loses one electron and thereby attains the electronic configuration of neon. This is because the only noble gas nearest to sodium is neon. Now you may ask me why sodium cannot attain the electronic configuration of helium or argon. Now, in order to do that, sodium has to lose nearly 9 electrons in order to attain the electronic configuration of helium, which is energetically unfavorable and a highly energy demanding process. And if sodium has to attain the electronic configuration of argon, it has to gain 7 electrons, which is again energetically unfavorable and a highly energy demanding process. So only possibility left for sodium element is that it can easily lose its only one valence electron, and thereby by doing that it can attain the electron configuration of neon, which is the nearest noble gas. Let's see in the animation. Sodium, it loses its outermost valence electron, results in formation of sodium ion, and sodium ion, it has exactly the same electronic configuration as that of neon. It is a stable inert gas, and this is because neon gas is nearest to sodium in the periodic table. Now what about chlorine? Now chlorine has to gain one electron to attain the stable electronic configuration of argon. So argon is the only noble gas nearest to chlorine in the periodic table. So chlorine can simply gain one electron and thereby attain the electronic configuration of argon. So it cannot attain the electronic configuration of krypton, because in order to do that it has to gain at least 18 electrons, which is again energetically unfavorable and a high energy demanding process. So easiest way of chlorine to attain the stable electronic configuration of argon is to simply gain one electron given by sodium. So argon is the only noble gas nearest to chlorine in the periodic table, and this highly favorable process. Let's see in the animation of chlorine. It gains one electron given by sodium, gets converted to chloride ion, and thereby it attains the stable electronic configuration of argon. So argon gas is nearest to chlorine in the periodic table. Now, formation of the common salt sodium chloride is energetically favorable, as I already explained, and it's an exothermic process. Excess of energy is being released, and this is due to transfer of electrons from sodium to chlorine. So this is why sodium loses one electron and chlorine gains one electron in order to attain the stable electronic configuration of the nearest noble gas in the periodic table. So if the number of electrons in an atom is greater than the number of protons, then the atom will have a net negative charge. Conversely, if the number of protons in an atom is greater than the number of electrons, then the atom will have a net positive charge. Let's try and understand this process using the example of sodium. So in case of sodium, it has 11 electrons. Its electronic configuration is 281. It has 2 electrons in the first energy level, 8 electrons in the second level, and 1 electron in the third level, which will be the valence shell. Now sodium single outermost electron is involved in its chemical reactivity, now, particularly when it forms ionic bonds by losing this electron to become a positively charged ion. So this ion, as we already discussed, attains the stable electronic configuration of neon. Electrically neutral sodium has 11 protons and 11 electrons. So it is electrically neutral with no net charge. That is to say, number of protons is equal to number of electrons. Oxidation state is therefore 0. When it loses an electron, that is the outermost valence shell, it becomes positively charged. This is due to ionization. That is, ionization, as I told you, it's a process which involves either loss or gain of electrons. Here sodium is losing electrons during the ionization process. Now sodium ion, has 11 protons and 10 electrons with a net positive charge. Why is that? Because the number of protons is not equal to number of electrons. Oxidation state is +1. The number of positive charges will be equal to the number of electrons lost by the atom. So here sodium has lost 1 electron and therefore it will gain a positive charge. So the number of positive charges equals the number of lost electrons. So sodium has lost 1 electron and therefore it has 1 positive charge. The sodium ion has 1 proton more than electrons. Magnesium ion has 2 protons more than electrons. Aluminium ion has 3 protons more than electrons. Now let me explain this in detail. Now ions are formed when atoms undergo a process called ionization, which you are already familiar with, which involves the gain or loss of electrons. The number of electrons lost or gained determines the charge of the ion. So here we have the sodium atom. It's electrically neutral with no net charge because in the elemental form it has 11 protons and 11 electrons. So number of protons is equal to number of electrons. So here you got 11 protons and 11 electrons within the nucleus of sodium atom. So this is before ionization. Now let's see what happens to the sodium in the elemental form after ionization. So during ionization, it loses the outermost valence electron. So this is what happens after ionization. It loses the outermost valence electron and now it is in the ionic form, Na+. Why? Because it has lost 1 electron. So it loses 1 electron. When it loses 1 electron, the number of protons will be more than number of electrons in the nucleus by 1 number. Therefore, you get 1 charge, 1 positive charge on the sodium. So now you know why sodium is having only 1 positive charge, because number of protons in the nucleus of sodium ion is more than the number of electrons in the shells by 1 number. That is why it has 1 positive charge. So sodium ion bears 1 positive charge because the number of protons is more than the number of electrons by 1 number in the nucleus. So when you are doing the counting, you have to do the counting with respect to the number of protons in the nucleus and the number of electrons in the respective shells of the sodium in the neutral form or in the ionic form. So therefore, sodium ion is bearing 1 positive charge. That is, number of protons in the nucleus is more than the number of electrons in the shells by 1 number. So the number of positive charges equals the number of lost electrons. So sodium ion loses 1 electron during ionization and thereby sodium ion has 1 proton more than electrons in the nucleus. So magnesium ion loses 2 electrons during ionization and therefore magnesium has 2 protons more than electrons. Aluminium loses 3 electrons during ionization and therefore aluminium ion has 3 protons more than electrons. The number of electrons in an atom is greater than the number of protons. Then the atom will have a net negative charge. Conversely, if the number of protons in the atom is greater than the number of electrons, then the atom will have a net positive charge. In case of chlorine, it has 11 electrons. The respective shells, its electronic configuration is 287. That's to say, it has 2 electrons in the first energy level, 8 electrons in the second, and 7 electrons in the third level. So chlorine is non-metal that gains 1 electron to form chloride ion. And this we have already discussed in detail why it attains the electronic configuration of argon, and it does so by gaining an electron from sodium. So chlorine has 17 protons and 17 electrons, and therefore it is electrically neutral with no net charge. That is to say number of protons is equal to number of electrons, and therefore the oxidation state is 0. So it gives 1 electron given by the sodium, and this results in formation of chloride ion. Now the chloride ion has 17 protons and 18 electrons with a net negative charge. Why? Because the number of protons is not equal to number of electrons. So it has got 1 electron more, and therefore it has 1 negative charge. Oxidation state is -1. Now the oxidation state changes from 0 to -1. Why? Because it has gained 1 electron, and therefore oxidation state will be -1. So the number of negative charges equals the number of electrons gained. So chloride ion has 1 electron more than protons. Therefore it has 1 negative charge. So oxide ion, in case of magnesium oxide, it has 2 electrons more than the protons, and therefore it has got 2 negative charges. Aluminium ion has 3 protons more than electrons in aluminum chloride. Aluminium has lost 3 electrons to 3 chlorine atoms, and 3 chlorine atoms have gained 3 electrons from 1 aluminium atom. In case of alumina, it is aluminium 6 plus and oxygen 6 minus. Now sodium chloride, the common salt, is formed by combination of elemental sodium and chlorine molecule. Now students are generally under the misconception that elemental sodium reacts with elemental chlorine. That is wrong, because chlorine exists naturally in the diatomic form. So chlorine does not exist as an atom, but as a diatomic molecule in gaseous form, and reacts with elemental sodium by redox process. And let us try and understand this redox process. So sodium loses 1 electron, attains the stable neon configuration. Chlorine gains 1 electron, attains the stable argon configuration. Sodium loses 1 outermost valence electron, and it is converted into sodium ion. So sodium is a metal that readily loses 1 electron from its 3s1 orbital in the outermost shell to form a positively charged sodium ion. It loses an electron from its outermost energy level, which results in stable electronic configuration similar to that of neon. So this ion attains the stable electronic configuration of neon. Sodium undergoes oxidation, that is, it is losing 1 electron from the outermost shell and is oxidized in the reaction. Now chlorine, on the other side, it gains 1 electron given by sodium and gets converted into chloride ion. So chlorine is a non-metal that gains 1 electron to form a chloride ion. This electron gain completes its outermost electron shell, making it more stable. So this ion attains the stable electronic configuration of argon. Now here in this process, chlorine undergoes reduction, that it has gained 1 electron, filling the outermost shell, and is reduced in the reaction. So sodium is undergoing oxidation while chlorine is undergoing reduction during the formation of sodium chloride due to reaction between sodium and chlorine gas. So in summary, ions are electrically charged particles formed by gain or loss of electrons by atoms. Cations have a positive charge because they lose electrons, while anions have a negative charge because they gain electrons. Ions are essential in chemical reactions and are therefore involved in the formation of ionic compounds and the behavior of acids and bases. Thank you so much for watching my video. Hope you enjoyed my video, and I'll meet you in my next interesting tutoring session.